Magnets, they're so powerful and useful. For example, they can attract certain metals to them, as well as make certain metals magnetic as well. They also have effect on electrical conductors, when the magnet and conductor are moving in relation to one another. And they can be used in medicine to produce three-dimensional anatomical images. So, what's the insane engineering involved in this? And how do magnets actually play a role? Well, to find out more, watch this video. Hey everyone, it's MJ Sanga, the creative engineer. Now, medicine, it's a field of science that has helped create vaccines and cure diseases. Machines have been built in this field to help find problems in the human body as early as possible. For example, to detect cancer or maybe other diseases. And an MRI machine is one of these. MRI stands for magnetic resonance imaging. It's a non-invasive imaging technology that produces three-dimensional detailed anatomical images. It's often used for disease detection, diagnosis, and treatment monitoring. The history of MRI includes the work of many researchers who contributed to what is known as nuclear magnetic resonance, and they describe the underlying physics of magnetic resonance imaging. This first starts with Nikola Tesla, who first described rotating magnetic fields in 1882, though he did not know what it was going to lead to. Later on, in 1937, Isha Rabi, a physics professor at the Columbian University, developed a method for measuring the movement of atomic nuclei, a state in which he decided to call nuclear magnetic resonance. He was later awarded the Nobel Prize in 1994. At first, his methods were mostly used to analyze the structures of chemical substances. And in the 1960s, a doctor named Raymond Damadian wondered if these same techniques could be applied to living organisms. It was in 1971 when he concluded that since cancerous tissues contain more water than healthy tissue, it could then be detected by scanners that bathe part of the human body in radio waves, and then it could measure the local emissions from hydrogen atoms. Around the same time, a chemist named Paul Latapa was at hard work using NMR to create images. He first started using vials of water, then clams, then he went on to green peppers. When he read Damadian's 1971 findings, he realized that his work could have biomedical applications as well. As years progressed, scientists began to make this a reality, and in 1977, the first magnetic resonance imaging exam was performed on a human being. Well then, what's the insane engineering behind these machines? Well, it all has to do with magnets. MRIs employ powerful magnets which create strong magnetic fields. These magnetic fields force the protons to align to their field. A radiofrequency current is then pulsed through the patient. This causes the protons to be stimulated. Because of this, they spin out of equilibrium, straining against the pull of the magnetic field. The radiofrequency is then turned off, and the MRIs have sensors which detect the energy released when the protons begin to realign with the magnetic field. It takes time for the protons to realign with the magnetic field, as well as the energy to be released. Changes depend on the environment and the chemical nature of the molecules. Because of this, physicians are able to tell the difference between various tissues because of the change in magnetic fields. So you may be wondering, what are its applications? Does it just scan tissues? Well, there are a few applications of MRI machines. By the way, if you're enjoying this video, please hit the like button and subscribe for more of my content. Back to the video. MRI scanners are particularly well suited to image the non-bony parts or soft tissues of the body. They differ from computerized tomography in that they do not use the damaging ionized radiation of X-rays. So no radiation, meaning that it's safe, right? Another use is that you're able to see the brain, spinal cord, nerves, muscles, ligaments, and tendons more clearly as compared to X-rays and CT machines. For this reason, MRI machines are mostly used to image knee and shoulder injuries. Another use is that in the brain, MRI can differentiate between white matter and gray matter and can also be used to diagnose aneurysms and tumors. Because MRI does not use X-rays or other form of radiation, it is the imaging modality of choice when frequent imaging is required for diagnosis or therapy, especially when related to the brain. However, MRI is more expensive than X-ray imaging or CT scanning. Although this is good technology and has helped human beings over the years, there are a few things we must take into consideration before allowing someone to do an MRI scan. One consideration is people with implants, particularly those with implants that have iron, such as defibrillators, nerve stimulators, and so on. Because of the strong magnetic fields, the iron will be attracted to the magnet. It's a high possibility that it can be ripped out of their body, which could harm them in the process. Another one is pregnancy. Pregnant women are not allowed to take an MRI scan. While there are no signs or proven evidence of the fetus being harmed, it is still taken into consideration that the newborn baby might be harmed in the process. Thus, they do not really consider a woman with a pregnancy to take these exams. Another consideration is what is known as contrast agents. Patients with renal failure that require dialysis may gain an illness known as nephrogenic systematic fibrosis that may be linked to gadolinium containing agents. It is still possible for them to take the MRI exam. However, they are required to do a dialysis after they take the exam. There are many things to consider before a patient can take an MRI exam. However, doctors make sure that they are capable or able to do one before they actually do so. MRI machines have helped doctors detect diseases in patients for over a decade or more, and they're continuing to do so. By the way, if you like magnets and you want to learn about electric motors, you can click the link right here. And if you like this video, please hit the like button and subscribe for more of my upcoming content. I really hope you enjoyed this video. Tell me what you think about MRI machines in the comments below. And I hope to see you again in my next upcoming video. Have a great day and thanks for watching.